So continuing with our bean example, suppose you have two neighbors sitting next to you in class, and they also take scoops of 120 beans. One has an interval that's 30.8% plus or minus 8.3%, and the other has 18.3% plus or minus 6.9%. So write out each of these in interval notation. So that's what I did. So I take 30.8 and I add 8.3 and I subtract 8.3, and that turns them into percentages. So 30.8 add 8.3, 30.8 take away 8.3, and you get 22.5 and 39.1, and those are percentages, and then I just turn them into decimals. Similarly, for this student over here, I got 18.3% plus or minus 6.9%, which gets me 11.4 and 22.5. 18.3 take away 6.9 is 11.4. 18.3 plus 6.9 is 25.2. So that's where those came from. So now I have a graph drawn here that shows the intervals. And let's pretend for some reason I think that the p-value is 0.2. The true proportion, and I highlighted it right there in yellow, is 0.2. What do you notice and what can you conclude? So if you look, there's the original interval we made. That was 17.3 to 32.7. Then there's the green interval, which is 22.5 to 39.1. And then the next neighbor was 11.4% to 25.2%, so 0.114 to 0.252. And you'll notice that the green one in particular does not contain p. It's not in there. So they've made an interval, but it doesn't have the true proportion. Well, that's to be expected because we had a 95% confidence level, and that means that 95% of the time your interval is going to contain the true proportion, but 5% of the time when you make a sample, it's not going to have the true value of p in it. So if you only took one sample, let's say you just take your scoop, you count them out, and you make an interval, you have no way of knowing if your interval is one of the good intervals that contains p or one of the bad intervals that doesn't contain p. Now, how often is this going to happen? Well, it's going to happen 5% of the time if you have a 95% confidence. So let's say we had 25 students and they all take a scoop, right? So every student comes up and gets a little scoop of beans, they count them out. So how many different intervals are you going to be making? You'll make 25 different intervals because every student will have their own data set. Every scoop is different, right? Every student's scoop will be its own thing. And therefore their intervals will all be different. So all intervals will be unique for all of the students. All right, what would that look like? I obviously didn't draw all 25 of them in here. I just drew some of them. So this is 1, 2, 3, 4, 5, 6, 7, 8. This is the first 8 students. First 8 students shown below, right? There we go. Okay, so there's the true proportion, p equals 0.2. It's technically supposed to be a horizontal line, but I hand drew this in class. And then you have your intervals built, right? And most people have the true proportion, but one person or a couple people will not contain the true value of p. Now, how often would we expect this to happen? Well, if you have a 95% confidence interval, you expect 0.05, which is 5% of those 25 intervals to not contain it. So 0.05 times 25 would be 1.25. So I expect 1.25 intervals to be bad, 1.25 people to have bad intervals that do not contain p. Now, if I had 2 of them, fine. But if I get 4, 5, 6 people that don't contain p, that's a sign that something else is going on. So we expect about 1 or 2 people, maybe 2. But if you get 4 people, 5 people, 7 people, 9 people do not contain p, that's a red flag that p is not actually 0.2. You assumed it was 0.2 because I said it was up here, right here, but you don't know it is. And if you get a whole bunch of people to have intervals that don't contain 0.2, that's a sign that what you assumed to be true about this is actually not correct. And that's where we're heading for chapter 10, right? You assume a certain value of your parameter and then you test it and you see, oh, so many people don't have that parameter. That's kind of a sign that that's not truly the parameter. And that's where we discuss that at great length in Chapter 10. All right, let's stop right here because this is the end of this example. I know it's a short video, but let's pause and let's meet back up here to watch the next video when we discuss what the actual formula for the population proportion is. So I'll see you back here then.